Okay, students, so this is lesson 1-1, variables and expressions. We're going to do, as always, we're going to have a little review right away at the beginning. I'm not going to really talk about this a whole lot. You can read this yourself, but I will leave the answers here and so you can check your answers. So I'm going to pause right now while you do this. You can check back with your answers. You should pause here also. All right, so we're going to do this problem in class tomorrow. But we'll start here with some examples of writing expressions with addition or subtraction. So my expression here is 25 more than the number n. And what I want you to think about is, if, like, let's say, a lot of times for our variable, let's just think of a number. So let's say my number is 100. Well, what would you do to get a number 25 more than 100? You would add 25. So our expression is the number n plus 25. That seems pretty easy. The order does kind of matter here. For addition is commutative, so you could say, well, you could switch it around. But when you say you want 25 more than a number n, it really means you're adding 25 to n. So the order is preferably that way. And you'll see that is more important when you're doing subtraction, because subtraction is not commutative. So if we want 74 less than a number n, so let's think of 100 minus 74. That's how you would find 74 less than some number. So we really have to subtract 74 from n. And in this case, this would totally not be acceptable. You actually will get the opposite of the number you're looking for if you do it that way. So think about 74 minus 100, that's actually a negative number. All right, now, on all these lessons, there'll be a second part to them. So here's the second part. What you're going to do here is try to do this on your own. I'll put the answers up for you to check yourself, but I'm really not going to talk a lot about that. So pause now, and you can go ahead and do that. So you should check your answers now. All right, and problem 2, here's another example. Now here we're going to do some multiplication and division. You have to know some words. Remember that product means multiplication and quotient means division. So product is multiplication, quotient is division. All right. So first one, we have 5 times number n. That seems pretty straightforward. Times is multiplication. And normally you would write it like that. Now the problem with that in algebra is that x is actually a variable we use a lot, so we're not going to use that symbol. So some of you think, well, I'm just going to use a dot. I'm okay with using a dot for a while, but eventually when you see a number and a variable with no symbol between, we're going to just know that that means multiplication in algebra. And for quotient, normally the quotient symbol is this, but I'm going to try and get you in the habit of using the fraction bar for quotient, and we want it in the order it's stated, n and 7, so that's going to look like this, n divided by 7. So we're going to try and get in the habit of using this. All right, go ahead, you try it. Check your answers. All right, writing expression with 2 operations. Again, the way it's stated will mean a certain thing. Like this first expression says 4 more than twice a number x. And if you think about real numbers, it might be something that 4 more than twice a number. So let's say our number is 25. So 4 more than twice 25 would be, the first thing you would do is multiply 2 times 25, and then you would add 4 to that. So that's the way our expression is going to look also. Instead of 25, we're going to put the variable x. And again, I'm going to try and not use a symbol when I'm showing multiplication. and 4 more than that would look like that. 7 less than the quotient of 8 and a number x. So the things that we're dividing are these two things, 8. And we need 7 less than that. So the first thing we want to do is divide those two numbers to get the quotient. And in that order, 8 divided by x, and then we want 7 less than that, so we're going to subtract 7. Again, the order matters here a lot. Both division and subtraction are not commutative. You cannot switch them around. So the product, that means times, of 9 and the sum of a number. So we're multiplying 9 and some sum. To do that, we're going to need parentheses. So we're going to take 9 times, now I'm going to try and not use a dot, and then I need a sum, and sum means add, and I'm adding two things. I'm adding x and 2. So that's what that's going to look like. All right, I'll let you try that. Go ahead and pause here. Check your answers. All right, now here we're going to put an expression into words. So our expression is 4x. Now remember that if there is no symbol, that's multiplication. So there's a couple ways we can do multiplication. And I'm going to try and get you in the habit of using the word. So we're going to use the word that means multiplication, which is the product. So we're going to start with the product because we know it's multiplication. And we need the product of two things, 4 and the number x. Product of 4 and the number x. All right. You could also just say 4 times x, or but I'm going to be specifically looking for your use of the appropriate words here. So go ahead, you try that. I'm going to pause now. All right, the last problem here has to do with writing a rule to represent a pattern that you see. And so we have to notice what's going on with these numbers to do that. And then we're going to write an algebraic expression for that. What you should notice is that as the hours go up by 1 hour every hour, you should notice that the numbers are going up by 750, which means that for whatever the situation is, renting a scooter, it's costing $7.50 per hour. So we're going to need to multiply 750 times the number of hours. But if we multiply 1 times 750, that's just 750. So there's some other part to this cost. So there must be something like a cost so that if you use it less than an hour, they still get some money. And it's not proportional to the other part. So if I do 1 times 750, I get 750. And if I subtract that from 1750, that leaves me with 10. So there's an added $10 to this cost. So it costs $10 plus $7.50 per hour. So that's how you would write an expression for that. So look for a pattern. And if it's going up by the same amount, the pattern is multiplication by something to figure it out. All right. Go ahead, you try it with this. Check back with your answers. All right, check your answers. And for this lesson check, what I'm going to do here is I'm either going to have you figure this out and put your answer on the computer. I'll give you a spot to do that. On this first one, though, I'm not set up quite to do that. So what I'm going to ask you to do is just to figure out what you think the answer is here for number 20 and for number 21, and to be ready to share that with the class. All right, that's it. I'll see you tomorrow.